In this video, I'll be solving question 7 of the paper 9709 that was done in February, March. That is Pure Mathematics 1, variant 2. Now, the question part A says, by obtaining the quadratic equation in cos theta, solve the equation tan theta sin theta equals to 1 for theta lying between 0 degrees and 360. So this is what you are expected to do in this question. Remember that the tan theta is given by sin theta over cos theta. So this is the same as, we can substitute is the same as sin theta over cos theta times sin theta equals to 1. So we can multiply this using the basic fraction operation concepts. You can have the sine squared theta over cos theta equals to 1. And this is going to give us what? The sine squared. And you know very well that sine squared theta plus cosine squared theta equals to 1. So this means that sine squared theta is the same as 1 minus cosine squared theta. So you can substitute in this equation. Therefore, we can have, in place of sine squared theta, we can put 1 minus cos squared theta over sine squared theta equals to 1. So you'll end up having 1 minus, this is over cos theta. This is over cos theta. Please take note of that. This is cos theta. So you'll end up having 1 minus cosine squared theta equals to, when you take 1 times 1 minus cos theta, you're getting 1 minus cos theta. Cos theta times 1 is cos theta. So we can take this one to the other side. It will become positive cosine squared theta. This one was positive. It remains the same way. That is cos theta, then minus 1 equal to 0. So now, this is now the quadratic equation. So you can as well let t be equals to cosine squared theta, not cosine squared theta, cos theta. So if t is cos theta, then cosine squared theta should be t squared. So this will be t squared plus t minus 1 equal to 0. So you can solve this quadratic equation. And this is how we are solving it. We can use the quadratic formula to solve. So using the quadratic formula goes to get the value of t is actually the same as what? This is 1. This is the same as what? Negative b. This is negative 1. Our b is the coefficient of t, which is 1. So we'll take negative 1 plus or minus the square root of. We can take 1 squared, that is 1, minus 4 into bracket AC. Our A is 1, our C is negative 1. So it's 1 times negative 1 divided by 2. So our T would be negative 1 plus or minus the square root of, this is 5, because we understand that negative 4 times negative 1 is positive 4. 1 plus 4 is 5, divided by 2. So this means that the value of t is either negative 1 minus root 5 over 2, or t can be negative 1 plus root 5 over 2. So what does it mean? We can now substitute the exact values. We can have the value of cos theta equals to negative 1 minus root 5 over 2. You can do that one in your calculator. And it gives you, let me get a calculator here, it gives you, so it's negative 1 minus root 5 over 2 is giving me negative 1 point. So cos theta equals to negative 1.618. Or you can have cos theta equals to, when you solve the other side, this one here, it gives you, we are having 0.618. So now to get the value of theta in the first case, let me just talk about here. So we can say theta is equals to cosine inverse of, ignore the negative to get the reference angle. So that's 1.618. So theta is given as what? This is the reference angle. Let me avoid calling it theta and call it reference angle. Reference angle to help me find my value of theta. So you can say cosine inverse of 1.618. I'm getting okay, let me just get it. It's okay, this one doesn't give this calculator, it has poor configuration. So let me just use the normal calculator. So this one does not exist. If you do with 1 point, it does not exist because the maximum cosine that you're having, it should be 1. So that one cannot exist. Yes, that one is an error. So this one here, we can cross it out. We don't need it. It does not exist. So what about the other one? So you can say theta equals to cosine inverse of 0.618. So our theta would be, so we can have the answer as 51.82. So it's actually 51.82 degrees. But they need the answer in the range 0 to 360. So it means that that one could be one of the angles. So you can as well get the angle, another angle using this circle that's called a unit circle. So unit circle, you just start from your this quadrant, you just say cast. It means that the angle that's giving the positive cosine is either in this quadrant or in this quadrant. So you can get the angle in this quadrant. And to get the angle in this quadrant, we take 360 degrees minus your reference angle. So we'll treat 51.82 because it's an acute angle. We'll treat it as our reference angle. So to get our second value of theta, we just take 360 degrees minus 51.82 degrees. And this one is giving us what? So that's 360 minus 51.82. It's giving us 3 or 8.18 degrees. So our values of theta are either 51.82 degrees or 308.18 degrees. Good. That is it for part A. Then for part B, they wanted you to get, they want you to show that tan theta over sine theta minus sine theta over tan theta is given by tan theta sine theta. Good. This is a very simple question. So what you have to do in this question is that you can consider the following, that tan theta, the way you see this tan theta, okay, tan theta is the same as what? Okay, we can start by getting the LCM. LCM is sine theta, tan theta. Anytime you find the denominators are different, just get the multiply them to get their LCM. So sine theta cancels sine theta and it goes here tan theta. So you're going to have tan squared theta minus tan theta cancels tan theta, so you're going to have sin theta, and sin theta times sin theta is giving us sin squared theta. So this means that you're going to have tan squared theta, which is sin squared theta, over cosine squared theta minus sin squared theta over sin theta tan theta. So here we can easily factorize. So we'll say sin theta into, that is a sin squared theta into 1 over cosine squared theta minus 1 over the denominator we are having sin theta tan theta. So we can cancel one of the sign here, and then we will end up having that is 1 over cosine squared theta, then minus 1, and then the whole of it, the whole of this one here multiplied by sin theta, multiplied by sin theta, then divide by what? Tan theta. Okay, guys, from here, it's very easy to show something. We can actually make this one to be in a fraction form, so we can get the LCM, which is cosine squared theta, and cosine squared theta goes there 1, so you're going to have 1 minus the denominator is 1. 1 goes into cosine squared theta times, and then this one will be times what? Sin theta, then the whole of it divide by what? Tan theta. So this one means that we'll end up having this one. We will end up having 1 minus cosine squared theta is the same as what? 1 minus cosine squared theta is the same as sine squared theta. Then over cosine squared theta, then times sine theta, then divide by tan theta. So this is the same as divide by sin theta over cosine theta. But remember, sin theta over cosine theta is the same as tan theta. So when you're dividing, we can actually multiply by the reciprocal. So we can say cos theta over sin theta. So here we can cancel sin theta, they go. Cos theta, this one and this one, it goes here 1 time, that is cos theta. So we end up having sine squared theta over cos theta. So this one you can split. We have sin theta times sin theta. Here we can do cos theta, and then here we can do 1. Now, what is sin theta over cosine theta? This is giving us tan theta, and this is sin theta. So we have actually shown it. Okay, see you in our next video. Thank you for watching the video. Kindly subscribe, comment, and share it with your friends.